Hello students and welcome back to our channel at the rate Uniclass 2.0. Today we'll be learning class 12 first chapter solutions. And please do like and subscribe our channel. We are getting a lot of views but no like and subscribe. So please like and subscribe our channel. Moving on. Today we'll be learning about solutions. What are solutions? Solutions are basically homogeneous mixtures. Mixtures meaning one or two components coming together and giving a uniform mixture. If we see, for example, if we take salt and water and we mix it very nicely, so you will see that salt and water cannot be distinguished from each other. So this is called a homogeneous solutions. We have any more other solutions like tea, coffee, and as I've shown, the solids like zinc and copper will combine to give us brass, where you cannot distinguish zinc and copper in brass. And if you see in how I've shown a tea for picture of tea and coffee, and in tea we have tea leaves, water and milk, sugar. They are all boiled together to give a uniform mixture. As well as in coffee we see the same process. Further on, now, solution is made up of two components. One is a solvent and the other is a solute. As you see, these both combine to give us a solution. Now, solvent, it determines the physical state of a solution. It determines whether the solution is either solid or it is either gaseous or it is either liquid. And it is present in large quantities. It is present in large quantities in a solution. Now the other components present in the solution may either being salts or any other metals or whatever, so it is present either in one or more quantities. They are known as solutes. Over here it is written solvent, but it is solutes. All right. Moving further. Now we come to the categories of solution. There are various categories of solution with regard to gaseous, liquid and solid solutions. I guess this slide is not that clear to you all, but I will try to explain it to you in a better way. Now, first we come to gaseous solutions, where the solvent is gas and the solutes are gas, liquid and solid. We see with the first example where gas is the solvent and gas is the solute. We have the mixture of oxygen and nitrogen gases. They mix uniformly. Now, gas and liquid, we have chloroform mixed with nitrogen gas. And in solids, we have camphor mixed in nitrogen gas. Camphor, when mixed in nitrogen gas, gives us a gaseous solution. Coming on to liquid solution, we have the solvent in the liquid form and the solutes in various gas, liquid and solid form. You see, oxygen dissolved in water. Gas and liquids example, we have oxygen dissolved in water. You know, the sea water or any other water bodies, they have oxygen present in them. That's how the aquatic life in water survives, via oxygen in the water. Now, liquid and liquid, ethanol dissolved in water. Ethanol is dissolved in water to give us an ethanol solution. Liquid, solid and liquid gives a liquid solution where glucose is dissolved in water. You've seen sugar, either sugar or any other types of sugar dissolved in water give us a liquid solution. We have solid solutions like gas plus where the solvent is solid and the other solutes are gas, liquid and solids. Over here we have an example of hydrogen in palladium for a gas and solid mixture, and liquid and solid mixture we have amalgam of mercury, which is also called as an isotopes of mercury dissolved in sodium. And solid with solid is copper dissolved in gold, where we have, where you see where we have don't have say 24 carats of gold, we have 18 carats of gold. So in 18 carats of gold we have some parts of copper mixed in it. All right. Moving further, we'll see how to express these concentrations of solution. Now, if in a solution, see if I have a beaker, and I have some water in it. and I have added some sugar or salt. I have added some sugar or salt to this water, and I have mixed it really well. Now I want to know how much, as in how much of sugar and salt I have mixed in this water. So I either can express this in quantitative or qualitative expressions. For example, now suppose I have mixed 1 gram of sugar in 10 ml of water. So the water will be approximately sweet. No, very not very sweet also, but sweet, normal sweet. So we can say that it is not that dilute. But if I say I mix 1 gram of sugar in 100 ml of water, so the water will be slightly sweet. This means that the solution is very dilute. So this is the qualitative property. I am trying to know what is the quantitative property. So qualitative, it will tell us how if the solution is dilute or concentrated. See over here, 1 gram plus in 10 ml is concentrated, somewhat concentrated. But in 1 gram in 100 ml is dilute. So in qualitative property, I will know it is either concentrated or dilute. But in the quantitative property, I will know exactly how much amount of a solute is present in a particular solution. Further, there are many types of factors which can determine the quantitative concentrations. One is mass percentage. Sir, please rewind the slide. Yeah. One is mass percentage, second is volume percentage, third is mass by volume percentage, parts per million, mole fraction, molarity and molality. We'll go through all these factors one by one. Moving further. Now, mass percentage. Now, mass percentage of a component is the mass of the component in the solution upon total mass of the solution in 100 into 100. Now, either if you want to find the mass of a solute, so the mass of the components or you can say mass of the solute upon total mass of the solution, or if you want to find the mass of the solution, so mass of the solution upon total mass of the solution. Solvent, actually this should be solvent. So either of these factors can be found out. Now sir, I have given an example of 10% glucose. Now how will I know I want to find the mass percentage? So here mass percentage is denoted by weight by weight. So when we have 10% of W by W glucose, it means mass by weight percentage. Now 10% of glucose plus 10% of what 90 grams of water, 10 grams of glucose plus 90 grams of water is makes a 100 gram of glucose solution. Glucose solution. Now this is used in commercial bleaching solutions, where we get to know how 33.62 mass percent of sodium hypochlorite is present in water. Means this is one example where I am showing you how solutions are made using weight by weight mass percentage. Next factor is volume percentage. Now over here, volume of a component is volume of the component upon total volume of the solution. Either we can say solute. If I want to find the volume percent of the solute, so I can say volume percent of the solute upon total volume of the solution. Or if I want the volume of the solvent, volume percentage of the solvent, then I can say volume of the solvent upon total volume of the solution into 100. Over here I have given an example of 10% volume by volume ethanol solution in water. Now that means 10 ml of ethanol in 90 ml of water. In the previous slide I have given these values in grams, but over there ethanol was not there, glucose was present. So So please keep in mind, in the previous weight by weight we have grams, and in volume we have ml. Moving further, mass by volume percent, it is denoted by WV, means W for weight and V for volume. Now mass, it is the mass of the solute dissolved in 100 ml of the solution. Mean whatever substance we have or whatever solute we have, it is present in 100 ml solution. Now, so I have given an example of 1% weight of volume sugar solution, where we have 1 gram of sugar dissolved in 100 ml of the solution. There is no particular formula for in this given in your textbooks, but I feel all the previous formulas will be applied to this. These formulas are very important regarding to your papers, because via this we come to know the amount of solution, amount of solvent or solute present in the solution. Let's move further. Now we come to parts per million. In parts per million, you see, I can give you a small example where suppose in a class we have 100 students, and in those 100 students we have a few students who do not score really well, they are very weak. So in those 100 students, 5 students means nothing, means very small quantity. So that in the same way, when a solutes are present in less or trace quantities, very less or trace quantities, so it is expressed in parts per million. Now parts per million is written as ppm. The short form is written in ppm. Now the formula is number of parts of the components upon total number of all parts of all the components in the solution into 10 raised to 6. Now for example, I have given here a liter of seawater. Now 1 liter of seawater contains 6 into 10 raised to minus 3 grams of dissolved oxygen, which is very, very less. So we express this in parts per million. Next. Coming on to the next slide, mole fraction. Now mole fraction is expressed in small x. Now mole fraction of a component is number of moles of the component upon total number of moles of all the components. Now if we come to a binary mixture, if the mixture has A component plus B component present, so the mole fraction of A is Na upon Na plus Nb, and mole fraction of B will be Na upon Na plus this will be B and B. Now for a solution containing I number of components, we have now for solution containing I number of components, we have xi is equal to Ni upon N1 plus N2 upon plus Ni, that is Ni upon summation Ni, that is number of components, I components upon total number of Ni containing all components. Now this can be shown in a given solution by sum of all the mole fractions, that is x1 plus x2 plus dot 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 xi. This is all summed up to 1. Now mole fraction is very useful in relating of a physical properties of a solution. Now we come up to molarity. Now molarity is the number of moles of a solute upon volume of a solution in liters. Now I have given an example where 0.25 mole per liter of solution of Na, so NaOH, that is sodium hydroxide. Now we have 0.25 moles of sodium hydroxide dissolved in 1 liters of water. Alright, let's calculate molarity. Over here we have, the question is calculate the molarity of a solution containing 5 grams of sodium hydroxide in 450 ml of solution. Now first we'll find out the moles of sodium hydroxide. We have 5 grams of sodium hydroxide in upon 40 grams per mole, which gives us a value of 0.125 moles. Now the volume of the solution in liters is 450 ml per 1000 ml per liters. Now, as we know, the molarity is the moles of the solute upon volume of solution in liters. So we'll keep note down all the values. Now this should be 450 upon 1000. So we have brought up 1000 on top on the numerator, where we get a value of 0.278 moles, which can be said as 0.278 moles per liter. Now molarity can either be expressed in m or moles per liter. Today we'll end this slide till molarity, and next we'll learn molarity in the next lecture. Thank you.